Okay, good day everyone. Welcome to another video lecture on analytic geometry. So today's discussion would be on the equations of the line. As for the coverage of of this content, we will be dealing with the different forms of equations for the equation of a line. Okay, so for each of the given form, we will be discussing each of the corresponding equation for each of the forms of a line. Okay, so in the equation of a line, we have the following forms for the equation of a line. We have the general form, we have the standard form, we have the two-point form, we have the intercept form, the point slope form, and finally the slope intercept form. Okay, so we'll start with the general standard form. Okay, so the general standard form of an equation of a line has the form ax plus by plus c is equal to 0. Now here in this equation, we the variables are the following: x and y, which corresponds to the values of the ordered pair in our Cartesian coordinate system. So this means that for every given point in our Cartesian coordinate system, x represents the coordinate of that point on the x-axis, and y represents the coordinate of that point on the y-axis. And in the general sense, the pair x and y would be point on the point on the line that has the form of this general form. Now, a, b, and c are considered the coefficients of our line. Okay, so this is the general form of the equation of the line. Try to notice that the degree of each of the given variable x and y has both of these two has the degree 1. That means if you're going to draw the corresponding given equation for this form, it is understood that the resulting equation would be the resulting graph for the general form of an equation of a line is of course a straight line. Now we know that if we're going to graph this general form, it is a line. It is because of the degree of the variables present in our equation. If it happens that our degree for the given variables is 2, so for example the form is ax square, this means that the corresponding graph of that line of that equation is not a line. So we know that based on the degree of the variables, we know that the corresponding graph for this equation is a line, simply because of the degree of the given variables x and y. Okay, so if we're going to transpose c to the other side and represent it again as a constant c, and then the general form becomes the standard form. So the standard form has the form ax plus by is equal to c. Okay, so next in our discussion would be the point slope and the two-point forms. Okay, so first would be the two-point form. The two-point form is that, of course, the basic idea is that if you want to form a line, the simplest construction of a line is you indicate 2 points and you connect them with a straight line. So that means for as long as you're given the coordinates of 2 points, you can actually form any given line for as long as you are given those coordinates. So for example, point 1 has the coordinate x1, y1. Point 2 has the coordinate x sub 2 and y sub 2. This would serve as points on the line L. Now, the equation of line L is given by this form. This is y minus y sub 1 is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1 times x minus x sub 1. Try to notice the subscripts present in our equation. Try to notice that all the x's and y's with the subscripts are the ones uh, who are the coordinates of the given 2 points. So x sub 1 is the x coordinate of the or of our point 1. Y sub 1 would be the coordinate of point 1 along the y. X sub 2 would be the coordinate of the second point along the x, and y sub 2 would be the coordinate of the second point on the or along the y. Now, those who do not have any subscript, such as this one as x and this one as y, is the given variables, such as just like what we saw or what appears here in the general form of an equation of a line. X and y represents our given variables. So that means any pair of values for x and y would be any point on our line L. Whereas x sub 1 y sub 1 and x sub 2 y sub 2 are specific points on line L. X and y represents an ordered pair without a specific value, but the value x y pair would represent any point along the line L or along or on line L. Okay, so let's take a few examples. Find the equation of a line passing through the following pairs of points. Write them in general form. Okay, so let's have this the solution for this set of examples. Okay, so this is the set of examples that are also present in the PDF form, but this is in Word form, so I'll be presenting to you the solution. Okay, so the first one is we are given the 2 points 2, 1, and 3, 2. So what is asked is for us to get the 2-point form. So what we do is we simply substitute the values for y sub 1, y sub 2, x sub 2, x sub 1. So correspondingly, we have y sub 2 minus y sub 1. If this is the second point and this is the first point, then this would be y sub 2, this would be y sub 1. So that means this is 2 minus 1. This would be x sub 2, this would be x sub 1. So in our 2-point form, x sub 2 minus x sub 1 for the denominator. So that is 3 minus 2. Then our corresponding variables, x and y. Y minus y sub 1, x minus x sub 1. So that is y minus 1, then x minus 2. Okay, so of course we need to simplify further. So this becomes 2 minus 1, 3 minus 2 becomes 1 over 1. 1 over 1 is of course 1. Then what is left here is you have y minus 1 is equal to x minus 2. Transposing negative 1 to the other side of the equal sign. Okay, so let me do that step. So what happens here is that of course 1 over 1 becomes 1, and then this becomes simply x minus 2. Then the next step would be to transpose negative 1 to the other side of the equal sign, and that becomes positive. So this becomes plus 1. Okay. Okay, so to simplify further, this becomes now as y is equal to x negative 2 plus 1 becomes negative 1. So therefore, this becomes y is equal to x minus 1. Okay, so this is the 2-point form. Now, the general form of the equation of the line has the form again ax plus by plus c, as presented in the previous discussion. So we have this general form ax plus by plus c is equal to 0. Now, what is asked in this example is that we are asked to get the form of the equation of the line and express it in the general form. Okay, so doing that, the given equation should be in this form. So this becomes x plus y plus 1 is equal to 0. as the general form. Okay, so this is the general form. We have x plus y plus 1 is equal to 0. Or, uh, okay, again, let me rephrase that. This becomes negative x plus y plus 1 is equal to 0. Since we are going to transpose positive x to the other side, that becomes negative x plus y. Negative 1, transpose it to the other side, to the side of y, that becomes positive 1. So this becomes negative x plus y plus 1 equals 0. Okay, so example number 2, we have 5, 3, and 2, 3. So doing the same for what just like what we have done in example number 1. Okay, so the result would be y minus 3 is equal to 0, or y is equal to 0. Now in the general form, if we're going to express this in general form, then the result would be y minus 3 is equal to 0. So this is actually the general form. Okay, so example number 3, we have 4, 1, and 1, 7. Okay, so just the same, what you're going to do is to substitute the values for x sub 1, x sub 2, y sub 1, y sub 2, and simplify further so that you would arrive in this form. So you have y minus 2x plus y. I am assuming that you will be going through the solution on your own, so I suggest that you do not rely solely with this video lecture, and I suggest that you do the same, or you do the calculation yourselves. Okay, so the last part of the solution is to express the resulting equation in general form. So in general form, this becomes 2x then plus y minus 9 is equal to 0 as the general form. Okay, so this would be the final answer, 2x plus y minus 9. Okay, so let's proceed now with the point slope and the 2-point forms. First, we have the point slope form. Okay, so the point slope form has the form y minus y sub 1 is equal to m times x minus x sub 1. Try to notice the form of the equation. It is called the point slope form. It is because you are given the slope m of the line, and you are given one point on line L. So the coordinate of that point on line L is x sub 1, y sub 1. Try to notice the form of the equation y minus y sub 1 is equal to m is equal to x minus sub 1, and compare it with the 2-point form. It is as though we have y minus y sub 1 is equal to m. This is the position of m times x minus x sub 1. It's as though m is equal to this expression, and this is not actually a coincidence, but it is actually the definition of your slope. The slope is actually given by this form. The slope is defined as y sub 2 minus y sub 1 over x sub 2 and minus x sub 1. This is not actually a coincidence, but it is actually the definition of m. Okay, so to fully understand the form of this equation, let's have the corresponding example. So given the slope of a line, given the slope and a point of the line, solve for the equation of the line in a slope-intercept form. So we're given this set of examples. Okay, so this is the same set of examples that will be presented here in this document. So we have number 1, we have the point 2, 3, and the slope equal to 3. Okay, so given the form of the equation of the point slope form, we have y minus y sub 1 is equal to m times x minus x sub 1. So we just simply substitute the values in the given form. So you have y minus 3 is equal to m, which is 3, times x minus 2 as our form of the equation by substitution. Okay, so to simplify further, this becomes y minus 3 is equal to 3 times x minus 3 times 2. It gives you 6. Of course, transposing negative 3 to the other side, this becomes y is equal to 3x this becomes okay, so let me edit this first. Okay, so this becomes y is equal to 3x minus 6 then plus 3. Okay, so to simplify further, what happens now is you have y is equal to 3x, you have negative 6 plus 3 gives you negative 3, so this becomes y is equal to 3x minus 3 in the form of y minus y sub 1 is equal to m times x minus x sub 1. Okay, so example number 2, we have negative 3, negative 1, 3, slope is given as 2. Okay, so this is direct substitution, so you have y minus 3 is equal to 2 times x plus 1. So you have y minus 3 is equal to 2x plus 2. Okay, so next would be is to transpose negative 3 to the other side, so this becomes y is equal to 2x plus 2 then plus 3. Okay, so next what happens now is you have y is equal to 2x, 2 plus 3 gives you 5. Okay, so this is the solution for example number 2. Next is 1 negative 5 and the slope is equal to negative 2. Okay, so substitution, you have y plus 5, negative 2 times x minus 1. Then what happens now is you have y plus 5 is equal to negative 2x. Negative 2 times negative 1 gives you positive 2. So next step is to transpose positive 5 to the other side of the equal sign. So what happens now is you have negative 2x, y is equal to negative 2x plus 2 then minus 5. Okay, so simplifying further, so this becomes y is equal to negative 2x, and then you have 2 minus 5 gives you negative 3. Okay. Okay, so next would be the slope-intercept and the intercept forms. Okay, so before we proceed with the form of the equation of the line for slope-intercept and intercept forms, let's consider first the following definition and theorems. Okay, so definition. The x-intercept of a non-horizontal line is the x-coordinate of the point of intersection of L and the x-axis. The y-intercept of a non-vertical line L is the y-coordinate of the point of intersection of L and the y-axis. Okay, so theorem, let L be a line and f of x and y equal to 0 be its equation. The x-intercept of a non-horizontal line is the value of x in f of x y is equal to 0 when y is equal to 0. And y-intercept of a non-vertical line is the value of y in f of x y is equal to 0 when x is equal to 0. So basically what this means is that the x-intercept and the y-intercept refers to the points on the x-axis and the y-axis where your line L passes through. Okay, so for example, if you have a line L, you have this coordinate system and you have a line L, from which point that the line L crosses your y-axis, that serves as your y-intercept. From which point the line L crosses your x-axis, that serves as the x-intercept. So in order to form the coordinates of the x-intercept and the y-intercept, of course the y-intercept is the point on the y-axis where your line L passes through. So therefore, its coordinates corresponds to 0, then y. Whereas the x-intercept is the point on the x-axis where your line L crosses. So that means its coordinates would be x, then 0. Okay, so knowing the definition of this theorem, let's consider the following examples. Solve for the x-intercept and the y-intercept of the following lines. Okay, so this is the same example that we saw in the PDF document. Okay, so this would be the solution. So for example number 1, we are given the equation for x plus 3y plus 1 is equal to 0. Okay, so in order to solve for the x-intercept and the y-intercept, what we need to do is to let y equal to 0, then solve for x. Now, solving for x means that we are solving for the x-intercept. It is because solving for the x-intercept here would form the pair, the value of x and y equal to 0. Thus, what we're going to solve for the value of x is actually the x-intercept. Okay, so doing that, we have we just need to substitute y equal to 0 in our given equation, so that becomes 4x plus 3 times 0 plus 1 equal to 0. So this term would be equal to 0. What happens in our equation is that it becomes 4x plus 1 is equal to 0. Then solve for x. You transpose positive 1 to the other side. This becomes 4x equals negative 1. Then dividing both sides by 4 so that you will have x equals negative 1/4. So therefore, our our x-intercept is equal to negative 4, negative 1/4. Okay, so doing the same for the y-intercept. So this time, to solve for the y-intercept, we let x equal to 0, then substitute that value 0 to our original equation. So what happens is this becomes 4 times 0 plus 3y plus 1 equals 0. Of course, this becomes 0. Then what is left is 3y plus 1. Transpose positive 1 to the other side, that becomes negative. Then divide both sides by 3. Then we can now solve for y. Y equals negative 1/3. Okay, so next we have 2x minus y plus 3 is equal to 0. Doing the same for computing for the value for the x-intercept, we let y equal to 0, then we solve for x. Okay, so the result is negative 3/2. I will not be discussing this in full detail. I will be just giving you this a copy of this document, and I am hoping that you will be reviewing this on your own. Okay, so next is doing the same for solving for the y-intercept. What we do is we let x equal to 0, then solve for y. So y becomes 3. Okay, as for example number 3, we have 2y minus x minus 4 equals 0. We let y equal to 0 to then solve for x. X equals negative 4. Then doing the same for solving for the y-intercept, let x equal to 0, then solve for y. Y is equal to 2. Okay, so let's proceed now with the intercept form. The intercept form of an equation of a line is of the form x over a plus y over b is equal to 1. Okay, so let's try to have some examples for the intercept form. Okay, so write the previous equations in intercept form. Letter B, let 5x plus 2y plus 1 equal to 0 be the equation of a line L. Write the equation in its intercept form. Then what is the x-intercept of L? What is the y-intercept of L? Okay, so this is the same problem that was presented in the PDF document. So what we see here is that letter A, we are first asked to write the previous equations from the previous examples in intercept form. So these are the previous examples. We have 4x plus 3y plus 1 is equal to 0. We are asked to convert this form of the equation of a line in intercept form. Okay, so what happens now here is what we have done here is we just simply reciprocate the value of 4 and we had it as negative, and the same goes with 3y. But actually the transition step between converting this form of an equation of a line to becoming this one is simply by transporting first negative 1 to the other side. of the equation. So if you're going to do that, this this is what happens in our given equation. So this becomes 4x plus 3y is equal to -1. Then in order to convert this into +1, we have to divide both sides by negative. So what happens now here is that this becomes negative 4x plus negative 3y, then plus +1. Okay, so to do that, what happens now here is that this becomes dividing both sides by -1, so that this becomes +1. Okay, so what we did is that we divided both sides by -1 to make this positive. So in effect, the 4x becomes -4x and 3y becomes -3y. Okay, so next step in our solution is to divide both sides by, or reciprocate the value -4 and the value -3, so that it would end up in the denominator. So doing that, what happens in our equation is that this becomes x over -1/4 plus y over -1/3. Now, why do we need to reciprocate our given equation in order to bring down the coefficient -4 to the denominator and the coefficient -3 to the denominator? So we did that simply because of the idea, or the idea that the form of the equation that is being asked is of the form of the intercept form, which is of the form x over a plus y over b is equal to 1. So our objective is to remove every coefficient of x and bring it down to the denominator. The same goes with your y. The objective is for us to isolate y. Any coefficient that would appear in besides y should be reciprocated down to the denominator, so that it would have this form of the equation. So going back in our solution, since we have -4 as our coefficient for x, in order to remove -4, we need to reciprocate -4 so that it would end up below the denominator as the denominator of x. So doing that, what becomes of -4 is that it becomes -1/4. The same goes with -3. -3 becomes -1/3. So therefore, this form of the equation becomes now x over a plus y over b, where a is equal to -1/4 and b is equal to -1/3. Okay, so next in our examples is example number 2. You have 2x minus y plus 3 is equal to 0. Okay, so first step is to transpose. Okay, so first step is to transpose positive 3 to the other side of the equal sign. So this becomes -3. Next step is to divide both sides by -3, so that the right side of the equal sign becomes positive. Okay, so doing that, this becomes +1, and okay, so this becomes 2x okay, so 2x divided by -3. Okay, so next is Okay, so this becomes negative y over negative 3. So 2x over negative 3 minus y over negative 3 is equal to negative 3 over negative 3, or that gives you 1. Perhaps I could write first the right side of the equation in the form of negative 3 over negative 3, so that it would be not too confusing on your part. Okay, so let me just copy this one. Okay, so what happens now here is that this becomes negative. This becomes negative 2x over 3. Next is this becomes plus y over 3. And finally, this the right side of the equal sign becomes positive 1. Okay, so next step in the solution is to remove all the coefficients of x and bring it down to the denominator. So doing that, that becomes x over negative 3 halves, and 3 is already in the denominator. So what happens now is that we have expressed the given equation in the form of x over a plus y over b is equal to 1. Okay, so last number for this example, we have 2y minus x minus 4 is equal to 0. Okay, so again, the first step in the solution is to transpose first negative 4 to the other side of the equal sign, or to the right side of the equal sign. Okay, so doing that, what happens now? What happens in our original equation is that this becomes 2y minus x is equal to positive 4. Next step is to divide both sides by positive 4. Okay, so this becomes negative x over 4, and you have 2y over positive 4. Okay, of course this becomes y over 2, and this is still negative x over 4. What happened here is I simply exchanged the position of x and y in the term here, and of course 4 over 4 gives you 1. Okay, so what happens now here is that we have expressed the given equation into the intercept form. X over a plus y over b is equal to 1. Okay, so part B of the example, we have let 5x plus 2y plus 1 is equal to 0 be the equation of line L. Okay, so we are asked for letter B. Number 1, write the equation in its intercept form. Then number 2, what is the x-intercept of L? And then number 3, what is the y-intercept of L? Okay, so first we deal with the equation 5x plus 2y plus 1 is equal to 0. And then the what is being asked here is to get the, or to express the given equation in intercept form. Okay, so just like what we did with previous examples, the first thing to do in our given equation is to transpose transpose positive 1 to the right side of the equation, so that becomes negative 1. Okay, so you have 5x plus 2y is equal to 1 is equal to negative 1. Then next step in the solution is to divide both sides by negative 1. Okay, so this is dividing both sides by negative 1, so that we can have this the right side of the right side of the equation as negative 1. Okay, so as positive 1. Okay, so this becomes 2y over negative 1, and then this becomes 5x over negative 1. Okay, so basically what we did is that we express this form as 5x plus 2y is equal to negative 1, dividing both sides by negative 1. Okay, so next thing to do is to um, remove all the coefficients of x to the denominator, and bring it down to the denominator. The same goes with y. So doing that, we should have the form of the equation as, okay, so this becomes negative 1 over 5. We no longer have 5 besides x. Okay, so the same goes with this one. Okay, so this should become negative 1 over 2, and 2y is no longer 2y but y, and of course negative 1 over negative 1 gives you positive 1. Okay, so we have expressed the given equation in the form of the intercept form, x over a plus y over b is equal to 1. Okay, so next in the given example is that we are asked to find the x-intercept and the y-intercept. Okay, so we have already I already presented to you the technique. So what we do is to get the intercept is to simply substitute the values of is to let y equal to 0, then solve for x, let x equal to 0, then solve for y. Okay, so what happens now here is that we let y equal to 0, and then substitute it for y in the given equation. What is left here is that x is equal to negative 5, and doing the same but this time for x equal to 0, we solve for y is equal to negative 1/2. Try to notice that the result for the intercept using the technique presented a while ago results into the same values for the coefficient of x and y under the denominator as a and b, so they are both equal. So that means you have actually several ways on how to compute for the x-intercept and the y-intercept. You could either start with the equation, converting the equation into the intercept form. It is understood that the resulting value for the position of A and the position of B would serve as the x-intercept and the y-intercept respectively. Okay, so next in our discussion is the slope-intercept form. So the slope-intercept form has the form y is equal to mx plus b. Probably this is the most familiar of any of the forms of the equation of the line, and the most famous among them. Y is equal to mx plus b. Okay, so again, y is equal to mx plus b. X and y are the given variables. M would be the slope of the line, and b is called the y-intercept. Okay, so I'll be finishing at this point of the discussion, and I'll be continuing with the discussion on the line on part 2.